Hello, Legacy students. Today we're going to look at what's known as Cramer's rule. Gabriel Cramer was a Swiss mathematician who basically is credited for using matrices to solve systems. So you're learning objectives. I can write the coefficient matrix based on a linear system, and I can solve a linear system using Cramer's rule. So why is this useful? Basically, what it's going to do is not make us do elimination. So let's try an elimination example using all the variables. Then you can see how the determinant will be useful in solving. So just follow. You don't need to write this down. So I have this problem. I have ax plus by equals c and dx plus ey equals f. So we're going to eliminate for y. Why not? So it looks like I need to multiply by e, right? So I'm going to multiply by e on the bottom and the top. So I'd have aex plus bey equals ce and minus bdx minus bey minus bf. So I multiplied the top by e and the bottom by b. Kind of like we would have multiplied by 2 on the top and 3 on the bottom, right? So that will be eliminating. And I will get aex minus bdx equals ce minus bf, right? So if I factor out an x and I see ce minus bf divided by AE minus BD. That looks familiar. Basically, it's the two determinants. So this is going to allow us to use Cramer's rule instead of doing elimination. So let's find the coefficient matrices. Basically, a coefficient matrix is the numbers in front of the x and the y out of a system. So if I have this linear system, ax plus by equals e, and cx plus dy equals f, the coefficient matrix is basically a, b, c, d. So that's the ones that are in front of the x and the y. Okay? The answer matrix is the two answers you have, so the two equal signs, e and f. So that's going to be a 2 by 1. What this is going to do, it's going to allow us to do Cramer's rule. So you're going to want to first build the coefficient matrix and the answer matrix in Cramer's rule. You're then going to want to find the determinant of the coefficient matrix. You're then going to find x. So you're going to replace the first column with the answer matrix and then find the determinant. So you're going to replace the first column of your coefficient matrix with whatever the answers were and then find the determinant of your new matrix. To find y, basically you're going to do the same thing. You're going to replace the second column of your coefficient matrix with the answer matrix and then find the determinant. To find your answers, you're going to use these two problems. You're going to use x equals the determinant of your coefficient matrix with the answer matrix put in, divided by what the determinant was to begin with. And y is this basically the determinant of the coefficient with the answer put in for the second column divided by the determinant of a. Let's try a few problems before we really start going, what is this? So here's a 2 by 2. I have this system, 8x plus 5y equals 2 and 2x minus 4y equals negative 10. So what I need to do, I need to first find the determinant or the coefficient matrix and the answer matrix, right? So your coefficient matrix looks like it is 8, 5, 2, negative 4, and my answer matrix is 2 and negative 10. Now, number 1, find your determinant of your coefficient. So let's find the determinant of 8, 5, 2, and negative 4. So 8 times negative 4 is a negative 32, minus 2 times 5, which is 10. So my determinant is negative 42. Now what I can do is use that to find my x and my y. So for number 2, my second step, we needed to find x. We're going to replace the first column, basically the one with the x's in front, with our answer matrix. So instead of an 8 and a 2, I'm going to put a 2 and a negative 10. And we need to find the determinant of this. So 2 times negative 4 is negative 8, and 10 times negative 10 times 5 is negative 50. So subtract a negative 50. So basically, I'm going to get 42, right? let's keep that in mind. Number 3, we now need to find the determinant of the coefficient matrix with the answer matrix put in for the second column. So basically, we're going to take this 2 and -10 and put it for the 5 and the -4. Because basically, it's whatever, these were with the y to begin with, right? So we're going to need to put the answer matrix for whatever had the y with it. Find your determinant. So 8 times -10 is -80. And 2 times 2 is 4. So I'm going to have subtract 4, right? -84. We're almost done. I swear it. So now what we need to do is take whatever we got for our x1 divided by our determinant. So x equals 42 divided by -42. So whatever you get here divided by your actual determinant. So that's just -1. So I know x equals -1. What about y? Y equals whatever -84 divided by -42 is, which is just +2, right? So I found my two answers. -1, 2 is the answer to my system. Now you're probably saying, that is a whole lot of work when I could have just done elimination. I hear ya. 2 by 2s, I would probably eliminate. But if you go to 3 by 3s or 4 by 4s or 5 by 5s, you need to be able to use Cramer's rule. Otherwise, you would go insane to try to do elimination. Let's try another example. So I have this system of 2x plus y equals 1 and 3x minus 2y equals -23. Let's write our coefficient matrix. So I have 2, 1, 3, -2. And then I have the coefficient, or the answer matrix, of 1 and -23. So, number 1, find the determinant of this bad boy. So 2, 1, 3, -2. 2 times -2 is -4. 3 times 1 is 3. So subtract, I get a determinant of -7. So now let's find the determinant of the coefficient with the answers in for x. So instead of that 2 and that 3, we're going to put a 1 and a -23 because we want to find x this time. There we go. Let's find the determinant. 1 times -2 is -2. -23 times 1 is -23. So I get a... Whoop! Gotta subtract, right? So subtract a -23, which is going to give me a +21. Almost messed up there. Number 3, basically the coefficient matrix, but instead of the second column, we're going to put our answer matrix. So 2 times -23 is a -46, and subtract 3 times 1, which is 3, so -49. Now, let's find our x and our y. So x equals whatever we got for number 2 divided by our original determinant. 21 divided by -7 is -3. And then y equals whatever we got for number 3 divided by -7, our original determinant, which is 7. So my answer to my system is -3, +7. Let's try with the 3 by 3. Maybe this is going to be easier. So, write my coefficient matrix. 1, 3, -1 for my first equation. -2, -6, 1, 3, 5, -2. My answer matrix is 1, -3, and 4. Let's find the determinant of our coefficient matrix. So this is going to take a little bit because you guys know how long it takes to do a 3 by 3. 5, -1, 1, -2, and then remember you have to duplicate the first and second column. Multiply across, I'll get 12. Multiply across, I'll get 9. Multiply across, I will get 10. So this is 31. multiply across, negative 18, multiply 5, multiply 12. So I will have 11. Whoops. Right? Oh, that's a positive 18. My bad. So that would be not 11. That would be 735, it looks like. So bottom minus top, 31 minus 35 is a negative 4. So my answer, my determinant is negative 4. Now, we're going to have to do quite a few determinants. I did the work ahead of time, so assume I'm right. You can definitely check my answers. You know how well I am sometimes. So number 2, basically what I need to do is find the determinant of the coefficient matrix with the first column, the answer matrix. So basically I'm going to rewrite, but my first column is going to look a little different than it normally did. My determinant for this particular matrix is a positive 2. No. Negative 8. It's a negative 8. Okay. I'm going to flip to the next slide so I can actually have more room to write. So our third step now is the coefficient matrix, but with the x in there. Or instead of replacing your x column, you're going to place your y column. So it's going to look something like this. 1, negative 2, and 3. And then 1, negative 3, 4. And then negative 1, 1, and negative 2. I did my determinant ahead of time, so I found the determinant was 0. Really nice there. Number 4, first step, now we have a z. So now I need to replace the z column with our answer matrix. So I'm going to have 1, negative 2, 3, 3, negative 6, 5, and then for my z column, I'm going to have the answer matrix. Just like before, I did my determinant early. My determinant for this one in particular was negative 4. So now, to find my x. So we're going to take what we got for x and divide it by what we got for our original determinant. So for my x, I got negative 8. So that was step 2, right? And I'm going to divide by our original determinant, which is negative 4. So I get x is 2. What about y? Well, I got y of the determinant for that one was 0, divided by my original determinant. So y is 0. Z is whatever my determinant is when I replaced with the answer matrix, divided by my original determinant, 1. So my answer, 2, 0, 1. Now you're probably saying, holy buckets, Miss Marsh. Do you expect us to do all of these 3x3 determinants? That's going to take us years. Well, come to class tomorrow and I will show you how to find determinants faster than fast. And with that, that's the end of this video. See you later, Sabers.